Right now, as you are watching this, 3 separate places on this planet are showing signs that something beneath the surface is shifting. In Kamchatka, Russia, the Sheveluch volcano has been sending an ash plume up to nearly 8,500 meters into the sky, continuously, for days. In the Philippines, Kanlaon volcano has been erupting on and off for over a week, forcing repeated aviation warnings across the region. And in the United States, Yellowstone, the volcano every geologist keeps one eye on at all times, just had a hydrothermal explosion rip through one of its most visited basins. 3 continents, 3 separate systems, all active in the same short window. This is not a coincidence video. This is not clickbait. Today we're going to break down what's actually happening at each of these 3 locations, what scientists are watching for next, and whether any of this is connected. No guessing, no dramatizing, just the facts, the data, and what it actually means. Before we get into it, drop a comment right now. Have you ever lived near an active volcano or felt a hydrothermal event like this one? Tell me where you were and what it felt like. If you want to be the first to know every time the Earth does something like this, subscribe. It's completely free and it genuinely helps this channel grow. A thumbs up also helps enormously. Let's go for 5,000 likes on this one so the algorithm actually shows it to people who need to see it. Thank you. Now, let's get into it. Let's start in the Russian Far East, at Sheveluch, one of the most active volcanoes on the entire Kamchatka Peninsula, and one that most people outside of Russia have never even heard of, despite it being one of the most consistently active volcanoes on the planet for the last several decades. As of this week, the Tokyo Volcanic Ash Advisory Center has been issuing continuous alerts on this volcano. The ash plume has been observed reaching an estimated altitude of 28,000 feet. To put that in perspective, that is roughly the cruising altitude of a commercial passenger jet. This isn't a single burst that fades in an hour. This is sustained, ongoing explosive activity, day after day, with the plume moving steadily outward at around 20 knots. For pilots flying anywhere near that region, this means active flight rerouting, because volcanic ash is not like a cloud you can simply fly through. Ash particles are essentially microscopic shards of glass and rock. When they get pulled into a jet engine at cruising altitude, they melt from the heat, then resolidify on the turbine blades, and in extreme cases, they can cause complete engine failure. This is why aviation authorities take these advisories so seriously, and why we've seen entire flight paths adjusted across the North Pacific during major ash events in the past. For the communities below the volcano, the concern is different, but just as serious. Ashfall blankets farmland, contaminates water supplies, and creates serious respiratory hazards, especially for children, the elderly, and anyone with existing lung conditions. Roofs can collapse under heavy, wet ash accumulation. Livestock can be poisoned by ash-contaminated grazing land. Sheveluch has a long history of major eruptions, some of them genuinely massive by historical standards. And the reason volcanologists watch it so closely right now is that this kind of sustained ash output can go one of 2 ways. Either it gradually fades out over the coming days as pressure releases and the system calms down, or it represents the buildup phase before something considerably larger. As of right now, the monitoring agencies tracking Sheveluch are treating this as an ongoing active hazard, not a resolved event. And that distinction matters because it tells you the story here is not finished. Now let's move to the other side of the Pacific, to the central Philippines, where Kanlaon volcano has been repeatedly erupting for over a week straight. This is not one dramatic explosion followed by silence. Ash advisories have been issued multiple times across just the last several days, with plumes extending in different directions depending on the wind. Northwest on one day, a completely fresh eruption just days later sending material in another direction entirely. What makes Kanlaon significant isn't a single catastrophic blast, it's the pattern. A volcano that erupts once and then goes quiet is often releasing a single pocket of pressure and settling back down. A volcano that erupts repeatedly and pulses over the course of a week or more is telling scientists that pressure is actively moving and continuously finding new pathways to the surface, rather than building toward one single release and stopping. That distinction, a single event versus a repeating pattern, is one of the most important signals volcanologists use when trying to assess where a volcano's activity might be heading next. Local authorities in the Philippines have been managing evacuation zones and exclusion areas around Kanlaon as a precaution throughout this period. And that alone tells you how seriously this is being treated on the ground by the people whose job it is to keep nearby communities safe. The Philippines sits on the Pacific Ring of Fire, the same horseshoe-shaped zone of intense volcanic and seismic activity that wraps around almost the entire Pacific Ocean. And Kanlaon is just one of several actively monitored volcanoes in the country at any given time. But right now, it's the one generating the most sustained activity, and the one aviation and emergency authorities are watching most closely. Now, here's the one that gets people's attention the fastest, because almost everyone has heard of it: Yellowstone. In June, a small hydrothermal explosion occurred in Biscuit Basin, one of the most visited geothermal areas inside Yellowstone National Park, a place where thousands of tourists walk along boardwalks every single week to look at colorful hot springs and steaming vents. Let's be precise about what actually happened here, because this is exactly the point where a lot of channels get it wrong, either by accident or on purpose, because a scarier version of the story gets more clicks. A hydrothermal explosion is not a volcanic eruption. It is not magma. It is not lava. It happens when trapped steam and superheated water beneath the surface build up pressure faster than it can escape through natural cracks and vents in the ground. And eventually that pressure blows a crater straight through the surface, sometimes throwing rock, mud, and boiling water dozens of meters into the air. It is dramatic. It is absolutely real. And it can be genuinely dangerous if you happen to be standing nearby when it happens, which is exactly why Yellowstone closes certain boardwalks and monitors thermal areas so carefully. But a hydrothermal explosion is fundamentally a surface-level plumbing event, a release of built-up steam pressure in the shallow groundwater system, not a sign that magma is rising toward an eruption from deep within the volcanic system below. According to the United States Geological Survey's official monitoring reports, Yellowstone's caldera, the massive volcanic depression that sits beneath the park, remains at completely normal background levels of seismicity and ground deformation. In plain terms, that means the deep volcanic system, the actual magma chamber far below the surface, is behaving exactly as it usually does, with no unusual uplift, no unusual swarm of deep earthquakes, nothing outside of its normal decades-long baseline. And what happened at Biscuit Basin was a localized steam event in the shallow hydrothermal system, not a signal of an imminent eruption, and it's important that we say that clearly here instead of letting a scary headline do the talking for us. Yellowstone experiences small hydrothermal explosions periodically. It's part of what makes the park's geothermal features so spectacular in the first place. The same underground plumbing that powers Old Faithful and the park's famous hot springs is also capable, on rare occasions, of blowing a crater somewhere unexpected. That's the honest, accurate picture, not the exaggerated one. So, why put these three completely different events into one video? Because this is genuinely how volcanologists and geologists approach their work. They don't just treat each eruption or each seismic event as an isolated headline sitting alone in a newsfeed. They track global activity levels as an ongoing, continuous pattern, comparing what's happening this week against long-term historical baselines to see whether anything stands out. Right now, in the same short window, you have sustained explosive ash output in Russia, repeated eruptive pulses in the Philippines, and a rare, localized hydrothermal event in the United States. Three completely different volcanic systems, sitting on different tectonic plates, thousands of kilometers apart, all generating activity in the same handful of days. Is that proof of some deep, hidden connection running beneath the entire planet? No, and we're not going to pretend otherwise just to make this sound bigger than it is. At any given moment, somewhere on Earth, a volcano is erupting. Global seismic and volcanic activity is happening continuously, every single day, all around the planet, most of it far too small or too remote to ever make headlines. What makes a window like this one worth talking about isn't that it's some rare cosmic alignment, it's that it's a genuinely useful reminder of just how much is alive and moving beneath the surface of this planet at any given time, and why the agencies responsible for tracking it, the USGS, the Tokyo Volcanic Ash Advisory Center, the Philippine Institute of Volcanology and Seismology, and dozens of similar organizations around the world, never actually stop watching. 24 hours a day, every single day of the year. It's also worth understanding a little bit about how this monitoring actually works, because it explains why scientists can speak with so much confidence about what is and isn't happening underground, even in places none of us will ever visit. Volcanoes are monitored using networks of extremely sensitive seismometers that detect even the smallest tremors happening kilometers beneath the surface, long before anything is visible above ground. They're monitored using GPS and satellite radar systems that can detect ground deformation, meaning this very slight swelling or sinking of the Earth's surface as magma or fluids shift underground, sometimes down to a matter of millimeters. Gas sensors track changes in sulfur dioxide and other volcanic gases being released, because a rising magma system often pushes gas ahead of it before anything else becomes visible. And satellite thermal imaging can detect subtle changes in surface temperature that might indicate heat moving closer to the surface. All of this data gets fed continuously into monitoring centers, where scientists compare it against years, sometimes decades, of historical baseline behavior for that specific volcano, because every volcanic system has its own unique personality, its own normal range of background activity. This is exactly why the USGS can say with real confidence that Yellowstone remains at normal background levels, because they aren't guessing, They're comparing today's data against an enormous historical data set built up over generations of continuous monitoring. This is also why sudden changes at Sheveluch and Kanlaon are being tracked so closely, because sustained, unusual activity stands out clearly against that same kind of long-term baseline. It's also worth talking about why these three particular regions, Kamchatka, the Philippines, and the western United States, are so volcanically active in the first place. Because none of this is random. All three sit directly on or near the Pacific Ring of Fire, a roughly 40,000-kilometer horseshoe-shaped belt that traces the edges of the Pacific Ocean, running from the southern tip of South America up through Central America and Mexico, along the west coast of the United States and Canada, across the Aleutian Islands, down through Kamchatka and Japan, and then south through the Philippines, Indonesia, and out to New Zealand. Roughly 90% of the world's earthquakes happen somewhere along this belt, and it's home to the vast majority of the planet's active volcanoes. The reason is tectonic plates. Along most of this belt, dense oceanic plates are being forced underneath lighter continental plates in a process called subduction. As that oceanic plate grinds downward into the mantle, it heats up, releases trapped water, and that water lowers the melting point of the surrounding rock, generating the magma that eventually feeds volcanoes like Sheveluch and Kanlaon. Kamchatka sits right where the Pacific Plate is being subducted beneath the Okhotsk Plate, which is exactly why it has one of the highest densities of active volcanoes anywhere on Earth, with dozens of active or potentially active volcanoes packed into a peninsula smaller than the state of California. The Philippines sits at an even more complex junction, where multiple smaller plates and microplates are colliding and grinding against each other simultaneously, which is part of why the country experiences both frequent volcanic activity and frequent earthquakes. Yellowstone is the outlier in this comparison, because it isn't part of the Ring of Fire subduction system at all. Yellowstone sits above what geologists call a hotspot, a plume of unusually hot material rising from deep within the mantle, largely independent of plate boundaries. The North American plate has been slowly drifting over this hotspot for millions of years, which is actually why you can trace a line of extinct, older volcanic calderas stretching from Yellowstone all the way back through Idaho, marking the hotspot's historical track as the continent moved over it. This is part of why Yellowstone behaves so differently from Sheveluch or Kanlaon, and why direct comparisons between them can be misleading if you don't understand the underlying mechanism driving each one. This is also a good moment to talk about how early warning and monitoring have changed the way these events actually affect people, because it's easy to watch a video like this and feel like there's nothing anyone can do when the ground starts moving or a volcano starts erupting. That's simply not true anymore, at least not in places with strong monitoring infrastructure. Volcanic ash advisory centers, like the one issuing continuous warnings on Sheveluch, exist specifically because of a string of serious incidents decades ago where commercial aircraft flew directly into ash clouds and suffered engine failures mid-flight. In some cases, losing power in all engines simultaneously before crews were able to restart them and make emergency landings. Those incidents led directly to the creation of the coordinated global network of volcanic ash advisory centers we have today, constantly tracking plumes like the one currently coming off Sheveluch and rerouting air traffic well before aircraft ever get close. In the Philippines, the Philippine Institute of Volcanology and Seismology maintains continuous monitoring on dozens of active volcanoes, including Kanlaon, and it's this monitoring that allows authorities to establish evacuation zones before a worst-case scenario happens, rather than reacting after the fact. And in the United States, the network of seismometers and GPS stations across Yellowstone is dense enough that scientists would very likely see weeks, potentially months, of clearly escalating warning signs, increasing earthquake swarms, significant ground deformation, changing gas emissions, long before anything resembling a major eruption could occur. That's precisely why the USGS can say with such confidence that current activity remains at normal background levels, because the system is specifically designed to catch meaningful change early, and right now it isn't seeing any at the deep caldera level. At the end of the day, it's worth stepping back and remembering that these aren't just abstract data points sitting on a monitoring chart somewhere. They're active volcanoes with real communities living in their shadow. In Kamchatka, there are towns and settlements that live with the reality of ashfall as part of daily life during active periods, adjusting everything from how they grow food to how they protect their water supply. In the Philippines, there are families right now who have been moved out of exclusion zones around Kanlaon, uncertain when they'll be able to return home, watching the news for updates the same way you're watching this video. And in Yellowstone, there are park rangers whose job right now includes managing a crater that appeared without warning in a place tourists were walking through just days earlier, reassessing boardwalk safety in real time, understanding the real science behind these events, what a hydrothermal explosion actually is, why ash plumes ground flights, why repeated eruptions matter more than single ones, doesn't just make for a more accurate video. It gives you a genuinely better understanding of a planet that is far more active beneath your feet, right now, in this exact moment, than most people ever stop to think about. We'll keep watching all three of these situations closely and bring you an update the moment anything meaningfully changes. Whether that's Sheveluch's activity finally winding down, Kanlaon settling into quiet, or if it ever happens, any genuine change in Yellowstone's deep monitoring data, which, as of today, to be completely clear, remains normal. If this kind of grounded, fact-first coverage is something you want more of, subscribing genuinely helps this channel keep making it. Let's try to hit 5,000 likes on this one together. Thank you so much for watching this. Stay curious, stay informed, and I will see you in the next one.